Hi everyone, I'm Jingyu Zhang. You can also call me Jack. So now our work is in changes in tweet geolocation over time, a study with Carmen 2.0. So for introduction, we know that Twitter geolocation tools are very useful for demographic studies in various topics, such as civil unrest, natural disasters, as well as studying disease spread. So existing tools for identifying the location of tweets are based on different types of data. For example, Twitter metadata, Twitter content, and also social network information. Our problem statement is that while these Twitter geolocation tools are widely used, they tend to only be English-centric, and they are often only evaluated on English or US data, and they are not evaluated across time and different languages. So we assess the following factors impact on geolocation tool Carmen. So these factors are language, country, and time. We first introduce an overview of Carmen. And so basically Carmen is a metadata-based geolocation tool that resolves location by using information from the tweet geo objects, place objects, as well as the Twitter user profile location. Down below is my Twitter profile page, and the circled Baltimore, Maryland location is my user location string. For Carmen 2.0, we made a couple of changes and made it compatible with Twitter API version 2, and did some performance optimization to make the geocode resolver 25 times faster. And more importantly, we expanded the internal database with GeoNames, a open source gazetteer, and we produced two versions. One is GeoNames only, and two is GeoNames plus the Carmen original database. For the Carmen original database, it has 7,000 location entries inferred from tweets between 2009 and 2012, which are mainly English tweets from the US. And it does not align with any external knowledge database. But in comparison, Carmen 2.0 have 73,000 location entries from extracted from the GeoNames database. And you have alternative names in many languages, and the location format is hierarchical, so it can be compatible with GeoNames. Now for evaluating geotagging performance, we should care about two different things. First is coverage, which is for word portion of data. The geotagger can propose a location. And second is accuracy, which is how well each of the proposed location compared to the ground truth. So essentially, we want the tool to be able to accurately cover a wide range of locations. Specifically, we build these different metrics for geotaggers. First is coverage, which measures the percentage of data that successfully map to a single location. And in terms of accuracy, we introduce different metrics. First, match ratio of level L measures the percentage of resolved tweets that is correct on level L, which is one of country, administrative region, and city. The second one is distance, which is the geodesic distance between the resolved and ground truth location. So lower is better. And accuracy at K, which is the percentage of resolved tweets, such as the distance error is under K miles. Now we conduct our experiments on a new Twitter geolocation evaluation dataset called Twitter Global. As the name suggests, it collects 15.3 million geotagged tweets between 2013 and 2021 that covers a wide range of languages and countries. We have the language distribution on the right, and you can see there are many languages, and we show the top 15 languages there. So now we evaluate the performance across different languages. We created two subsets of English and non-English data from the Twitter global datasets. And we found that on non-English data, GeoNames substantially increased coverage, which is highlighted in the right circle, and also a moderately increased accuracy-based metrics, such as mapping ratio and accuracy at K. For performance across countries, we created two subsets of US and non-US data from Twitter Global, and we found that on non-US data, geonames also substantially increased the coverage, and also it achieved comparable accuracy with the original Carmen database. For performance over time, we created different subsets of Twitter Global for each year between 2013 and 2021. And we find that due to the change in Twitter metadata availability, the coverage dropped significantly after 2014. However, even in the case of this metadata drop, we find that geonames still provide slightly better coverage regardless of the metadata scenario. For summary, we introduced Carmen 2.0, an updated version of the geotagging tool Carmen, and Twitter Global, a new evaluation dataset that covers a wide range of language and locations. And we found that there is significant difference in performance across different subsets of data with English versus non-English and US versus non-US tweets. And then our conclusion is geolocation tools should be robust to language, country of origin, as well as metadata availability. So we admit that more work is needed for fine-grained studies, for example, on each individual countries and each individual languages. And that's all for the presentation. Thank you for listening.